This is Captain Chaudhari in my series of videos on marine astronomical navigation. Today I am going to do a very special kind of question which sometimes was done by the people out at sea earlier when the GPS or sat-nav or these satellite based navigation systems were not there, right? And we used to solely bank on astronomical sites. Sometimes cross Pacific you would not find the stars or sun for days together, and then one fine day, if master saw a star through the break of clouds, he would immediately call the duty officer and he would say, shoot that star. We will see afterwards what that star is, but first take the altitude of that star, and the time used to be noted down, right? In fact, the time in terms of chronometer was noted down. In case we have identified the star, we might as well find out the position line related to that star. So we'll try to do a question, right, whereby we see an isolated star, through the sky which was generally overcast otherwise, right? Let's do a question. This is from my book. The question is, on the 5th May at 12:52 GMT. On 5th May at 12:52 GMT, in position 20 degrees 12 minutes north, 20 degrees 12 minutes north, right? 112 degrees 24.5 minutes east, 112 degrees 24.5 minutes east, right? A star on azimuth 82.5 degrees, right? With altitude, that is the true altitude, 44 degrees 14 minutes was found, right? Now you have to identify the star. In any question where the star has to be identified, we basically have to find out the declination and SHA of the star. So if we have declination and SHA from the almanac, there is a list of stars where the stars are listed in increasing order of SHA. So we try to see the SHA and declination which is matching, that must be the star. So I suggest the students that wherever latitude or declination is not given, you place the body according to altitude and azimuth. Now this star is on the azimuth 82.5 degrees, right? And the altitude of the star is 44. So star is somewhere here, right? And the latitude of the observer is about 20 degrees 12 minutes. So if I divide this part into 9 segments, around here the equinoctial would come. So north celestial pole would be here. So we can draw the observer's meridian. The various things which are available are, one is azimuth 82.5 degrees, and when we have the latitude which is 20 degrees 12 minutes, we have the PZ as 69 degrees and 46 minutes. 69 degrees and 48 minutes. Altitude was 44 degrees 14 minutes. That means this part was 44 degrees 14 minutes. So zenith distance, that is ZX, would be 45 degrees and 46 minutes. So we have two sides and included angle known. So whenever we have two sides and included angle, we can use the cosine formula to find out the opposite side, right? But in this case, the opposite side is, say, small z. So we can write down the cosine formula like for small z, that is cos of other sides right? Cos of small z is equal to cos of other sides, that is cos 69.8 cos 45 degrees 46 minutes plus sine 69.8 sine 45 degrees 46 minutes cos of opposite angle, that is 82.5 degrees, and this is nothing but this is cos of z or cos of the polar distance. Let's find this. (70 degrees 48.8). So what I get is 70 degrees 48.8 minutes. So that is the polar distance. 70 degrees 48.8. So the declination, which is the distance from here to here, should be 90 minus polar distance. So that should be, so 19 degrees 11.2, you can see that the star is north of equinoctial, so declination is north. So this is the declination of the star. Now, having found the polar distance, that is 70 degrees 48.8 minutes, now we know all the three sides. So it would be easy for us to find out what is this angle that is at pole. Because this angle is on the east side, this angle is EHA, and to find out P, we should actually first write down the formula for side P. So side that is opposite to the angle P is side P. So cos of side P is equal to cos of, this is side X and this is side Z, cos Z cos X plus sine Z sine X, into cos of opposite angle, that is capital P, and therefore cos of angle P is equal to cos of small p minus cos Z cos X divided by sine Z sine X. So that means it's equal to cos of small p, that is 45 degrees 46 minutes minus cos of 70 degrees 48.8 minutes cos of 69.8 minutes divided by sine 70 degrees 48.8 minutes sine 69.8 minutes. So this will be equal to cos of internal angle P. Let's do this. What we have is cos 45 degrees 46 minutes 48 degrees gives me the EHA as 48 degrees 46.64 degrees. EHA is 48 degrees 46.64 degrees. So once we have the EHA as 48 degrees 46.64, this, if I subtract from 360, will give me the LHA. So LHA of the star is 311 degrees 13.35 minutes. 311 degrees 13.35 minutes. Now in any question where identification of the star is asked, the question must directly or indirectly give the information about the Aries. It may be given as local sidereal time, whereby we multiply local sidereal time by 15 to get LHA Aries, or it may be given as the Greenwich mean time of the observation or the local time of observation, whereby we can find out GH Aries, and from GH Aries we can find out the LHA Aries. So let us see in this question how the information in respect of Aries is given. So the question says that the observation was made at 12:52 GMT. So at 12:52 GMT, we must find out what is the GH Aries. So from the almanac, let's look at the GH Aries for 12:52 GMT. The GH Aries was 56 degrees 38.7. 56 degrees 38.7 is the GH Aries, and the observer's longitude was 112 degrees 24.5 minutes east. Longitude east, we know G least, which means that the LH Aries should be more. That means we should add this and we get 169 degrees 3.2. This is the LH Aries. But LHA star is 311 degrees and 13.35. And we know that SHA star is LHA star minus LH Aries. So from the LHA star we should subtract LH Aries to get SHA star. 142 degrees 10.15 is the SHA of the star, and declination we have found before only, right? So let us see the matching star with declination about 19 degrees and SHA about 142 degrees is Arcturus. Arcturus is the star. So the star which was seen was Arcturus. So there is a list of stars with the increasing order of SHA, right, in somewhere on the middle of almanac, and in the star identification or in the listing of the star on the left hand side we have a kind of a name that is based on constellation, and on the right hand side or in the middle of the page we have the popular name. So normally the star, when we answer in the question, we should write down, state the name of the star which is in the middle of page, and that star is Arcturus.